So we travelled up to the Australian Institute of Marine Science last year in December to collect sperm cells around the annual spawning event. Now they bring corals in from the Great Barrier Reef to this amazing facility that can hold corals in aquariums, and we can separate those out at specific times of the evening and collect their germ cells so that we can cryopreserve those. So in December 2020, during our trip to AIMS, we collected material from corals that had been collected from reefs in the northern Great Barrier Reef, as well as local reefs around Townsville and Cairns. The material that we collected were from a variety of species. Some of them we already have represented in the bank, and so any additional material is really good for us to expand the genetic diversity of those coral species. But we also were able to freeze some sperm samples from 3 new species. New species to us, but existing species on the reef. And we now have 29 species represented in our bank. So we've now been collecting materials since 2011 is when this program started. So that material that we've collected represents animals and areas that may have been impacted by bleaching events in that time. So we have some very valuable genetics represented in our bank. Over the 10 years that we've been collecting material, we've now got samples from corals that have been collected from the northern Great Barrier Reef, central Great Barrier Reef off Townsville and Cairns, and also the southern Great Barrier Reef around the Keppels and also Heron Island. So that's important to get genetic representation from all of those different areas, but also those have different microclimates, so they might have different tolerance to heat or other environmental challenges that may be important to represent in our bank as well. So over that 10 years, we haven't only been collecting material, we've also been investing in research and development for the application and use of the material for conservation efforts. And one of the things we have shown is that we can thaw out this material again and use that sperm to fertilise fresh eggs and produce larvae and produce new coral recruits with very little loss in fertilising potential. So that's a really important step for us to have got to be able to show the application of this in a broader context of conservation. So the successes we've had over those last 10 years has been a collaborative effort with a number of different institutions, in particular for the research and development of these technologies in Hawaii with the Smithsonian Institution. Now that we've been able to apply some of the things that they've learnt there to Australian coral species, and now we're really excited to be part of Australia's Reef Restoration and Adaptation Program, which is going to open doors for us to link with collaborative partners who are really interested in utilising this technology to forward their conservation programs. At Taronga's Cryodiversity Bank, we have the largest bank of living coral cells in the world, and we're really excited for the next phase of this program to expand our technologies, expand our sample sizes, collaborate with new people with new ideas, and to really move this forward to help the Great Barrier Reef survive climate change.